Welcome to Algebra 1. The learning goal for this episode is how to solve equations that have variables on both sides of the equal sign. Let's look at some examples. We typically solve these equations by trying to get the variables to one side of the equation and the constants to the other side, then solving like we have previously. In this example, our variable is x, so we want to get all the x's on one side of the equal sign. We have two choices. We can either move all the x's to the left side of the equation by subtracting 5x from both sides, or we can move all the x's to the right side of the equation by adding 2x to both sides. It's important to understand that you can do either of those choices. They are both correct, but we usually choose whichever one we think is going to be easier. In general, adding is easier than subtracting, so I'm going to choose to add 2x to both sides. This now gives us a two-step equation that we know how to solve. We want to isolate x, which has been multiplied by 7 and had 17 subtracted from it. So first, we're going to add 17 to both sides. Now we want to do the inverse operation of multiplying by 7, so we're going to divide both sides of the equation by 7. This gives us a solution to the equation with x being equal to 3. But as we've seen before, we can check our solution to make sure it's correct. We rewrite the equation. Then we substitute in the answer we got, in this case 3, for the variable x. Then we simplify. Since both sides of the equation end up being equal, we know our solution was correct. Let's try another example. Again, our goal is to isolate the variable y in this case. In this case, we notice that not only is the variable on both sides of the equation, but on the right side, we can use the distributive property to simplify. So our first step is to distribute the 1/8 by multiplying it through the parentheses, giving us 3y minus 6 on the right side. This now looks just like example 1. We can either choose to move the y's to the right side of the equation by subtracting 2y, or we can move them to the left side of the equation by subtracting 3y. Both methods are correct. In this case, I chose to subtract 2y because, in general, I know I'm less likely to make a mistake when working with positives instead of negatives. If I had subtracted 3y from both sides, it would have left me with a negative y on the left side. That's perfectly fine, but I'm more likely to make a mistake that way, so I chose to subtract 2y instead. Now this is a simple one-step equation. I add 6 to both sides and simplify, giving me an answer of negative 6. Now we can check our solution by rewriting the original equation. Then we substitute negative 6 for y every place we see a y. Then we simplify. Since both sides of the equation are equal, our solution is correct. Let's look at example 3. We actually have two equations here, I'll call them 3a and 3b, that we want to work through to see some special cases. For both equations, I use the distributive property to simplify one side of the equation. Now in both equations, I'm going to subtract 2d from both sides of the equation. On the equation on the left, 3a, notice how all the d's subtract out and we are left with 0 equal to negative 12. Is that possible? And on the equation on the right, notice how the d's subtract out and we are left with negative 12 equals negative 12. Is that possible? Well, for the equation on the left, no, it's not possible. 0 is not equal to negative 12. No matter what we try to substitute for d, we can never make the two sides of this equation equal. Therefore, we say this equation has no solution. We can either write out the words no solution, or often we use the mathematical symbol for no solution, which is a 0 with a diagonal slash through it. Now, for the equation on the right, negative 12 is always equal to negative 12. So in this case, no matter what we substitute for d, both sides of the equation will be equal. That means this equation works for all possible values of d. We call this an identity, and we say the solution is all real numbers. Now for our guided practice section, we're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So, for this problem, our first question is, what are we trying to do here? What we're trying to do is isolate C, or perhaps get C by itself. Your next question is, what's our first step? Our first step is to apply the distributive property to the left side of the equation. We always want to simplify each side of an equation as much as we can before we start doing things to both sides of the equation. So what's our next step? Our next step is to try to get all the c's to one side of the equation and all the constants to the other side. So what should we do next? We could either subtract 2c from both sides of the equation or subtract 5c from both sides of the equation. Either would be correct. I chose to subtract 2c from both sides because I knew that would leave me with a positive number of c's, which is easier to work with. Now what? To isolate the 3c, we subtract 17 from both sides of the equation. What's next? Now we divide both sides by 3 and we get our solution of c equals negative 11. What should we do next? We should check our answer. How do we check our answer? We start by rewriting the equation. Then what? We substitute in our answer, in this case negative 11 for c. Now what? We simplify, and our solution checks. Let's go through that process with another example. What are we trying to do? Isolate the variable w. What do we do first? We simplify the right side of the equation. How do we do that? We use the distributive property to multiply 4 times the w and times the 8. Now what? Now we can combine the 4w and the negative 20w, giving us 32 minus 16w on the right side of the equation. What's next? Well, that depends on whether you notice anything special about both sides of the equation. If you do, then you can answer the problem right now. But we'll go ahead and finish working the problem just to make sure it's clear to everyone. So to continue working, we'd want to get all the w's to one side of the equation and all the constants to the other. So we'll add 16w to both sides. Now what? Well, 32 is equal to 32 all the time, and it doesn't matter what we substitute for w, it will still work. So this is an identity. So what's our answer? The solution is all real numbers. We can substitute in any number for w and it will work. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video and work out the problem, then press play to check. Here is the solution and the check. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution and our check. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve equations when we had variables on both sides of the equal sign. We did that by simplifying and combining any like terms on each side of the equation, then getting all the variables to one side of the equation, then solving like we have previously. Remember that you can always go back and replay portions of this video if you need to see it again.